Hey YouTube, this is Rishika. This would be my 20th video tutorial on 20th video tutorial on data stage. So in my previous three tutorials, just the previous tutorials, I explained about join, merge and lookup stages. So yeah, I explained in detail every property and all that, and now in this video I gonna explain the key points and the key differences in interview point of in interview point, the differences between join, merge and lookup stages in the interview view, in the interview point of view. Okay, so yep, here we go. So join, it can handle large volumes of data, and even merge can handle large volumes of data. Okay, so basically the join, merge and lookup, if you have seen my earlier videos, you'd have probably known by then that these three stages are just performing the join operations. That's it. Okay, join operations are being performed by these three stages on different tables. Okay, so yeah, join and merge stages can handle large volumes of data because the incoming data is, I said, for the join and merge stages the input data must be partitioned and sorted, right? So because the input data is already partitioned and sorted, it gonna have like little memory use, so that's little memory use. So obviously when there is like less memory usage, we can handle large volumes of data, right? So yeah, but when it comes to lookup, it can handle only less volume of data. This is important because this is this is another interview question. They say, okay, you say that lookup is only used for less volume of data. So sometimes people may ask why. So the reason is lookup stage basically it uses its own cache memory. So but the thing is the cache memory is very limited. So if you want to handle or if you want to process large volumes of data on by this lookup stage, so the memory is, because the cache memory is limited, right? So when you're trying to read large volumes of data, the memory is overflown, and the memory is overflow, and to accommodate all the large volume of data, this lookup stage tries to create its own its own additional disk files. So in that process, when additional disk files are created, it's gonna create additional disk files because it is trying to it is trying this lookup stage is trying to have lookup on each record of that huge volume of data. So yeah, in the process of that, additional disk files are created, and in order to if number of additional disk files are created while performing lookup, this stage checks or perform lookup operations on each additionally created disk file, right? So first of all, it doesn't have enough memory, it has only limited memory. And second thing is because we are trying to reach more because we are trying to read out of the more memory, more we are trying to read more data than it is expected, the memory is overflown. Next is, even though the memory is overflown, the stage still tries to read the all the huge data, and in that process it's gonna create additional disk files. Okay, and the next thing is, when additional disk files are created, this lookup stage, what it does is it tries to look up or perform check operations or lookup operations on these additionally created disk files. So yeah, so if say there are like three okay, so let's say we have only cache memory, we have only like, let's say 10 MB, and for each additional disk file it's creating, let's say, like just minimal amount, so let's say 20 MB. So basically it looks for only 10 MB, but because we are making it very huge volume, it gonna additionally check upon each 20 MB, and let's say we have like 5 different additional disk files. So yeah, it needs to look up on those 5 different additional files with 20 MB of data, right? So that's pretty huge for lookup, and for that reason the performance issues occur. So whenever there is like huge volume of data, go for join and merge, and when there is less volume of data and you need to perform join operations, depends on what type of join you're looking for, go for lookup stage. Okay, So that's pretty much in detail explanation about why lookup doesn't handle, can't handle, it can handle, but it's not good, it's not a good option to handle a huge volume of data. And the other important difference is join can have any number of input links except full outer. If you remember full outer, we can have only two input links, left and right. And if you try to put more output links, more input links, it just accepts, but when you're trying to compile it, it throws some error that it can't accept more than two input links for full outer join type of operation. And a merge stage can have any number of input links, and lookup can have only one input link. Okay, input link, the mainstream link is one, but it can have n number of reference links. Okay, and coming to the output links, join stage can accept only, can have only one output link, and even merge stage can have output link. I'm talking about output links. Okay, output links can be counted to reject links, but now let's just make it output link. And lookup stage, even that's one output link. And the main thing is, yeah, join stage does not accept any reject link. And merge stages, if you remember, it accept, if you have like n input links, it gonna accept n minus 1 reject links. So n input links are like master links, and n minus 1 are like reject update links. You remember, right? If you don't, just check back to the merge video tutorial. And lookup stage, it can have one reject link. So they can ask, so you have large volume of data, so which stage do you choose among join, merge and lookup? So join, you say, okay, let's say join, and they say, okay, I want to collect reject records. So then I don't want to use join, then say it's merge. So then they're gonna ask how many reject links can I have and all that stuff. So that's a basic difference. And the links, some guys, they even ask, they really, if they really want to know, like, did you really work on those data set, these stages and all that, they're gonna ask something like, okay, you are saying that you're working on join, merge and lookup stages, but just let me just tell me what are the link names when you use join, merge and lookup, like, because they don't have the same link names, right? So yeah, so you need to you need to know that too. So join, whatever the first, whatever the link we give, it's left, right, and all other links are intermediate links. No, it's not limited, we can have any number of intermediate links, but the first and the last one would be left and right links. And we can change sorry, and we can change this left and right, which thing does what, we can change it in link order though. And coming to the merge stage, the first is the master link or the master data or the driver data, and all other links are just the update links. And coming to the lookup, the basic thing is the primary input data. It's basically called primary input data, and all other reference links which you're trying to have lookup on the primary input, those are all called lookup links. So if, let's say, you have two lookup links, it's gonna have lookup 1 and lookup 2. So that's it, lookup link 1, lookup link 2, and that's it. So yeah, this is not a big deal, but still some of those guys ask, so I'm just making sure you know these two. And join, by now you should know that join performs 4 different operations, 4 different types of joins: inner, left outer, right outer, and full outer, right? And merge can perform only 2 joins, inner and left outer. Remember, unmatched masters mode keep, it's inner, and if it's keep is left outer and drop is inner. Okay, and lookup also can perform only 2 joins. If you have seen my video, it says continue means left outer and just drop or reject means inner, right? So that's pretty much about this. And yeah, the other thing is, yeah, input data must be partitioned and sorted for join and merge stages, but lookup stage, it doesn't require the input data to be partitioned or pre-sorted, because even though if it's partitioned or sorted, we obviously need to check every record for lookup, right? So it doesn't really make sense for sorting, because by default we're gonna choose entire partitioning, and if it's already partitioned, it doesn't really make sense, because obviously we're gonna choose entire again. So yep, that's pretty much about the differences between join, merge and lookup stages. I'm pretty sure they're not gonna ask anything more than this. you can say like this, like memory wise it's volume of data, handling large volumes of data. Link wise, then operations wise, and then that's it. These are three: memory wise, link wise, and operation wise. These are the three main differences. And the other things like reject link wise, I mean reject links and partitioning and all that, it's pretty much it's additional information for them. So yeah, that's pretty much it about this join, merge, and lookup stages. That's it guys, thanks for watching, and I'll make a video pretty soon. So thank you guys, thank you so much for watching.